Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek. In lecture 7, we looked at VMs on containers and I came across this YouTube tutorial. It is about VMs and containers and it's a good introduction. It's only 9 minutes long, so I recommend to watch it. The following YouTube channel
What's the
is
difference
this
between
one.
Docker and virtual machines or
So
VMs?
take a look at it. They also talk about use cases
These
here, starting with
microservices. This is probably the most common
the
use
first
for
use cases for
containers.
VMs, then the
The
use
Docker
cases
containers
for
lightweight
containers. Here I disagree a bit. So with respect to the use cases, I would rather say it's for deployment and container orchestration services like Kubernetes. And another use case is for the local setup for developers, which he mentions in his second point. Nevertheless, I think this is a good introduction into VMs and containers, so please watch it. The next article is about crypto regulation. It's the following article here. It's about the European Parliament adopts crypto-focused MiCA legislation. MiCA, or the Markets in Crypto Assets Regulation, is a proposed regulatory framework introduced by the European Commission. It was already introduced in September 2020. And the goal of MiCA is to establish a comprehensive and harmonized set of rules for crypto assets and related services within the EU. And MiCA covers a wide range of topics, including the classification and issuance of crypto assets, requirements for crypto asset service providers, and provisions for stable coins and utility tokens. However, MiCA will not apply to crypto asset services provided in a fully decentralized manner without intermediaries. And Binance already announced they will implement this regulatory framework into their platform. The next article is about security. It's the following article here. It's about the case where French police was able to crack an encrypted hard drive. It is estimated that they were using 10,000 servers with GPUs. So in this article, it's about a password that's supposed to have a length of 20 characters, and they are estimating to have used something like 10,000 computers with GPU acceleration to actually brute force this password. So the question is, are passwords with 20 characters not safe anymore? Well, not necessarily. The KDF that was used, PBKDF2, which is the default in Ubuntu 84. KDF is a key derivation functions which generate private keys with enough entropy by adding random bits, so-called salting, for the private symmetric keys that was used for AES. And PBKDF shows its age. It was designed before the age of those super fast GPUs. And this article basically explains why other mechanisms such as Argon 2 are better. So this article here down explains why we should use Argon 2. And the key mechanisms of those new key derivation functions is that it uses memory and the memory bandwidth. And this is also difficult for GPUs to parallelize, and the memory also in the GPUs, it's not much faster than the traditional memory in computers if you compare it to the compute speed. So the compute speed on a GPU is insanely fast. However, the memory speed is, it may be a bit faster, but not in that range where the compute speed is compared to GPU and compared to a CPU. And also a very interesting comment from Clemens Fruert. He's the author of Lux, and this encryption system that was used in this Ubuntu machine. And he says that with 13 character password, you should be safe. And he thinks, and this is a quote, it is much more likely that there were some security failure in the leaked case other than PBKDF2. That said, he still supports upgrade to Argon 2 to this better KDF function. Nevertheless, a very interesting article about what key derivation functions are and what those properties of those key derivation functions should be. Me personally, I'm using Ascript for various projects. It's also memory hard, so you also need memory, and it's also difficult to compute on a GPU. So there are also alternatives to Argon 2. The next article is about also about forensics, about crypto detectives. It's the following article here, and it is about people who are investigating on-chain transactions, and they also mention Chainalysis, a company that tracks those transactions on-chain, Bitcoin, Ethereum, and is currently now valued at $8.6 billion after a founding round last year. And those detectives are becoming important, as for example in the FTX case I was also reporting, and there they are investigating where those funds are, who got those funds, who transferred those funds to which accounts, and basically trying to figure out who did what. And Chainalysis has active contracts with the federal government. They are worth roughly 65 million US dollars, but there are also competitors, for example, TRM Lab, which now work both on the FTX case to figure out the transactions, who send what in which direction. And this is a good reminder that Bitcoin and Ethers and other tokens can be tracked, and to stay anonymous, use a privacy-oriented chain, for example, Monero, or even use a centralized exchange. They will cooperate with the governments, but your transaction will stay anonymous for others. And this is also a reminder for an upcoming talk at OST in Rapperswil. The title is also with respect to forensics. The title is From Digital Crimes to Court in the UK. It's by Philip Anderson, and it's also about digital forensics. So it's from 1 o'clock to 5 o'clock in room 5002. If you're there in Rapperswil, please join us. Then the last article is about local first software. It's this article here. It argues that offline is just online with an extreme latency. And it's an article about a YouTube video from Peter van Hardenberg, and he talks about AutoMerge. It's a CRDT library. It's this talk here. It's a very interesting talk. It's 45 minutes. If you have time, please watch it. He explains what they're doing, how they're doing, also a bit of history and what a CRDT are, and he also shows a simple demo. CRDT, this we will look into in the upcoming fall semester. And CRDT are conflict-free replicated data types. It's a data structure designed for distributed systems to achieve strong eventual consistency and high availability. CRDTs enable multiple replicas of data to be updated independently and concurrently without the need for coordination or locks, making them suitable for applications that require low latency and high fault tolerance. So this is just basically a Git merge without the conflicts. Yes, that exists. Well, not the Git merge without conflicts, but there are algorithms and mechanisms where this is possible. And he makes a good example about the current state of distributed systems. It's here, that one. You want to work with the coworker on a piece of software. If you're in the same room, sitting at the same table, looking at the screen side by side, any communication between those two computers is actually happening by sending signals across the ocean to some data centers, to other servers, and then coming back to you. And also quite interesting is this graph down here about latency, that we have real time below 300 milliseconds, web requests, well, 30 seconds is a lot for a web request. And then you have here extreme latency, almost up to 30 days. And as latency increases, the potential for trouble increases. So if you work with these kind of peer-to-peer systems where one can stay offline for a longer time, those are much more difficult to build than traditional client-server systems.